Welcome to this month's iTrain. Today we have Katharina Immer, who is going to walk us through the ALMA Observing Tool. So Katharina, whenever you're ready.
Yeah, hello everyone, and thank you for joining this iTrain. Today I want to give you a walkthrough of the ALMA Observing Tool, especially in preparation for the upcoming ALMA deadline. So let's see first, what is the ALMA Observing Tool? So it's a Java-based application that consists of a set of user interfaces, and it's used on one side by the users to prepare observing proposals, but also to schedule the approved observations in phase 2. Today, I will only focus on the phase 1 side, so how to prepare a proposal. And there are 3 more links to the reference manual, the user manual, on the quick start guide of the OT, where you can get more information, which is all accessible from the Cycle 11 documents page on the ALMA Science portal. So where can I actually download the OT? So I'm giving you here the link, and there's 2 ways of installing the OT. There's the installer, and there's also the tarball. And on both pages, there's information on how to do this. And just as a comment for Mac users, if you're having the Mac 14.4.0, please update to 14.4.1, because there's an issue with Java which might make the OT to crash unexpectedly. For Windows 11 users, we also had several help desk tickets already, so please install the OT via the tarball. The installer seemed to have some issue with Java as well. So just a short summary of the most important points of what's new in Cycle 11 in the OT. So there is now new capabilities, and I'm only mentioning here some. The whole list you can find in the user manual, for example. At the beginning of the user manual, there's the full list of changes. But we can now observe band 1 in full polarization with a 12-meter array, and also band 1 on the ACA is now allowed, but also for Stokes I. And this is also the first time that all bands are allowed for all 12-meter configurations. A very important point that has been changed and that might cause some confusion is that the configuration assignment in the OT has changed. So now we're actually basing the assignment of the configuration on new tables that take into account a larger range of available antennas. Which means that the OT and the scheduling subsystem are better aligned. But it also means that for certain angular resolution values, you might not get an answer anymore from the OT, because this is actually not schedulable in this way. So the OT will tell you from the beginning if these values are possible or not. I'm happy to take questions about this later if you have questions. And for large programs, there's one change now as well, that PIs have to confirm the scheduling feasibility of their proposed observations. So how do you actually start the OT? So I will show you this in a moment as well. If you started from the installer, you go to the folder it makes in your applications, and you hit the almaot.command file. And unfortunately, due to some changes on Mac, for example, it is now done in a way that it opens a shell from which the OT is started. Please do not close that shell while you're working in the OT. So this is kind of the walkthrough that I will give you today. We'll mostly focus on regular proposals and then go through the different sections of the OT. So talk about the proposal information, the field setup, spectral setup, calibration, control, and performance, and the technical justification. But I will also mention the specifics for large programs, joint proposals, solar observations, target of opportunity, and for phased array and VLBI. The 2 iTrains ago, we actually had a focused one on VLBI, so there's also a section about the OT part in that iTrain. And if you have any questions about the OT or any issues, or you need help with your proposal preparation, please either contact the help desk, use the Department Observing Tool, or within 3 days of the deadline, please use the Proposal Submission Emergency Department. And of course, you can always contact your local ARC node, either through the help desk or directly contacting the nodes. They're also very happy to help you with your preparation. Okay, so now let's start looking at the OT. So as I said, you go into your applications folder, you find this ALMA OT C11 2024 one. You click on ALMA OT command, and then, as I said, this shell opens. And the OT starts. This takes a moment. Okay. Moment longer than I had expected. No. Okay, and I would ask you what you want to do, and we will start creating a new proposal. You can also make a DDT proposal. You can open a project from disk, or you can retrieve one from the ALMA Science Archive, but I will focus now on the new proposal. And this is then the view that you get in the OT. So you start with clicking on proposal, and you can start filling in some proposal information. So for example, this is a great ALMA proposal, and you want to get some abstracts describing what you want. So please give me time to observe amazing things. So then the next section is the proposal type. So as I said, I will first focus on the regular proposals, but we will also go through these different options later. So you can click on regular, and then you have to choose your scientific category. So I'm mostly working in star formation, so I will go for this one. And you have to select one or two keywords. So you select them by clicking on them, and then if you're on a Mac, if you press down the command, you can also select another one. So for now, this is not a joint proposal, so we keep this at no, and then we have to select the PI. So you can say here name contains, and I can look for my own name and add that here, and you see now that my name is put in here. So I can also add co-Is to this. So for example, I want to look for, there are way too many Lopez's. I wanted to look for Anna. Anna, you're not in here? Okay.
Sepulcre, maybe.
Yeah, okay. There we go. Good. So, and then I can choose who is the reviewer of this. So for now, you can either click on yourself, but you can also choose a co-I as a reviewer for your proposal. If you choose a co-I, then make sure that that co-I has a PhD. Otherwise, if it's a student project, the student can be a reviewer as well, but only as a PI. And that you have to specify down here. So if you say reviewer has a PhD, so for now I would say yes, but you can also say if it's a student project, no, but then you have to select a mentor. And I could do this again by entering a name. Let's see, we have this person, and then this person has to have a PhD. So I have to put yes here, otherwise the OT will complain later. And let's leave it at yes for now. And then on the last step for here, you can attach your science case, which is a PDF of maximum 4 pages for regular proposals. And please make sure that most of the text in there is at least 12-point font. Okay, so you're done with this part of the proposal. Now you can go and add a science goal. So the science goal had several sections. General field setup, spectral setup, calibration setup, control, performance, and technical justification. Because it's easiest, I will start with a spectral setup. Here there are different possibilities. So you can have either spectral line observations, continuum observations, or a spectral scan. So I will start with a single continuum, and here you have all the different receiver bands, and you can choose whatever is the right one for your science. So let's say we choose band 6, and then you can see the DOT by itself makes this kind of setup for you. However, you can also say, I don't like these frequencies so much, I will prefer they're slightly higher, and then you can go in here and change the sky frequency, and then again, the DOT will calculate this for you. Let's say we prefer this, so we set it back to the standard frequency that it has. Then here you can then give the representative frequency, but let's say you don't like this frequency, but you actually want to have it at 240 gigahertz. So for now, the OT is complaining because my representative window that you can set here on the side is set to 242 gigahertz, and this does not contain the 240 gigahertz. So if you want to do this, you have to switch to this baseband being representative window, and then you can see that you can change it to 240 gigahertz. There's also in low spectral resolution for your continuum setup, you cannot change your bandwidth or your resolution, but if you click here and you choose high spectral resolution, then you can change the averaging. And you can see that here, right now I have a velocity resolution of 1.5 kilometers per second. I can change it with spectral averaging up to a factor to a value of 10.5. Now, there's also the possibility of specifying which polarization products are desired. So probably most of you will leave it at dual, but you can also just have a single polarization observation. And that again shows you how your bandwidth, when your resolution changes, or you can also go for full polarization observations. So this is single continuum. You can also do spectral line observations, and there are two ways of putting windows here. So either you can add a window manually and then enter the frequency that you want. And for example, put this frequency, and then you have to select the correlator mode. And you see that there are these different options here. You see right now that there are only 2-bit options because I'm still in the full polarization setting. So if I go back to dual and select, then you have the 2-bit and the 4-bit options that you might be familiar with already. So now we can choose, for example, if we want to do continuum for now, then we can set this this correlator mode here. And then we can also add spectral window centered on a spectral line. So we can go here, and that will now open another window which accesses the Splatterlog catalog. And then you can type in whatever frequency you want. You can do filters here to find the different transitions and so on. So for example, if I just put in CO, then if you double click, it gives you here the line that you would make a spectral window for. And then you can just click OK. And then you find this here. And then again, you can specify your correlator mode for this. So for here, we can, for example, do this one. And so this way you can start building your whole spectral setup. So for example, we can center it on another spectral line. We can find 13 CO, for example, with another spectral window.
Tata?
Yeah.
There is a question from one of the participants who's asking what would be the reason for someone to choose XX or double X instead of dual?
That is a good question. It is not really really supported anymore. It is just, I think you can, I mean, that changes what kind of resolution you can reach, but yeah, normally the observatory prefers dual. Not sure if that answers the question very well, but I think it's just for very high resolution observations that really require much higher spectral resolution. Okay, and let's finish this setup here. So let's find another line. No, something like this. And a correlator mode again. And you see that you can have all these different kind of correlator modes, right? You can have 1 and 2-bit and 4-bit, but if you choose 4-bit, then it has to be 4-bit the same for the baseband. Oh no, there can only be one 4-bit window, spectral window for your baseband. Okay. So now we have our setup, and the OT is not complaining so far, so this all looks good. So this is how you set up spectral lines. And then what you can also do is a spectral scan. Spectral scan, you just enter which frequency range you want to cover. And for example, you put this, and then the OT will calculate how many spectral windows you need and how many tunings you need. And you can also change again the bandwidth for this. And then you see that the OT complains now if I put a much smaller bandwidth, because you can only have up to a maximum of 5 tunings. So this is actually covering then a much smaller frequency range. If I stay at the larger one, then it's happy and it gives you the whole range. Good. So if you're thinking about what you want to do, and then you said, no, I don't want to do a spectral line, let's go back, spectral scan, let's go back to a spectral line, you see that the OT remembers the setup that you did before. So let's keep going with this setup. We should give this a name here, because otherwise the OT complains. And then we can also have a look at the spectral line viewer. So you can see in here, you can zoom in this, and you can see now how the OT puts the different windows that you specified. Okay, and you can then see if this falls well into your into the basebands, and also if you have spectral windows overlapping, for example, etc. So this can be very helpful. Okay, so now that we have a spectral setup, we can go and say which source we want to observe. So you can either put this in manually and say, this is my favorite source that I want to observe at a -5° declination, or you can also specify source name and then push on resolve, and it will give you the coordinates, but also fills in like parallax and proper motion information. You see that, for example, for this source here, although it has a LSR velocity, it actually is not given in the catalog, so I can put this in manually myself if I know the value and if I want to. You can also, for extragalactic observations, for example, you can change the Doppler type, so there's different definitions here. You can use optical and relativistic, and put in the redshift, for example. So depending on what kind of spectral setup you have, you then have to specify for your source what kind of continuum flux, and what kind of, if you have a spectral line observation, what kind of line flux you're expecting for your source. So let's say we expect Jansky here, and you also, for your line, when you have spectral line observations, you have to give a line width. If you put the polarization to full and you want to do polarization observations, and you also have to specify what kind of polarization percentage you're expecting in your observations.
There seems to be another question, if you don't mind interruptions.
Not at all.
What is the meaning of the continuum light blue line in the spectral setup chart that was shown? Yeah, I presume.
Light blue.
I was also trying to figure out what. So
I think sorry, this is not working. The different blue lines show
the vertical lines. Okay.
The vertical lines give, so these ones here give you where the center of your spectral window is. And one of them is darker blue for being the one that I'm clicking on, I think. So if I click on the other one, then the other one gets darker blue, I guess. Oh no, that's brighter blue. This is the same blue. So the one that I'm clicking on gets a different blue. You see now that the continuum is shown. Not sure if that answers the course that the blue that they were looking for.
Yeah, hopefully, but let us know if that answered your question. Thank you.
I can also go back to this later if the
the participant said thank you, so I guess okay. Thank you.
Good. It looks like there might be more questions. Is there something else? Okay. Good.
Not for now.
Not for now. Okay. Good. Then let's go back to the field setup. So then there are two ways. So either you can just have one pointing on your source. This is probably the most typical one, or you can define a mosaic for your source. So this can be done with individual pointings or with a rectangular field. So individual pointings, you can enter here in the field center coordinates section, and you can add just different pointings, and then you can specify, I don't know, I need to make 10 arc seconds away, 20, 30. So depending on what kind of frequency you're observing at, this then gives you different pointings, different sizes, of course, for your 12 or 7 meter array. So you can enter them either in relative coordinates, or you can enter them in absolute coordinates if that is in any way helpful. You can add pointings, as I did. You can delete pointings if you don't want them anymore. You can reset to 0. You can import them from a file, and you can also export them if you want to plot them for yourself. If you want to see how this actually looks like, you can also use this spatial viewer here, and there are different, either you can load in your own image file if you want, or you can use any of these image servers here. And that then shows you where your source is, and then these red circles, they give you the size of your pointing. And you can show it either with you can show just the position, so you can show the antenna beam size around it. If you put in individual pointings, then make sure that per source, these pointings actually overlap. Otherwise, the OT will complain. If you want to put in individual pointings for the same source that are not overlapping, then you have to put them in as separate sources. If you want to put in a separate source, you can go down here and say add source. And then you will get another source. It looks like this. It's all empty again. If you said, yeah, but I want to have a source that is exactly like the other one, can I just copy the information somehow? You can do this, and you can go back to your source, and you can say clone source. And you see that you get a copy, and you can say, okay, that's not a great name. Let's call it 1. So all the names that you give your sources in a science goal, they need to be unique. So this has to have a different name than the first one. But you see that it copied all the information from before, including the pointings as well. But then you can put in a different pointing here if you want that is offset from the rest. And in that way, you can build up your own mosaic, so to say, if you want to. This is a possibility, or you can also do it rectangular field. So in a science school, you cannot mix individual pointings in rectangular fields. So we have to go and actually get rid of these sources that we put in here. Delete the source. So you see, you can delete source, delete all sources. You can, again, load them from a file and export them to a file, similar with the pointings. And if I then say, okay, I don't want to do individual pointings, I actually want to do a big mosaic, you go to one rectangular field, and then you can give an offset of the center of the mosaic that you want, either in relative or in absolute coordinates. And then you can just specify a length. And that will give you, again, you can come here, query this, and this will give you the size of your mosaic. And you can also put in a position angle here. If you say this is not the right way, you can also turn it around, and you can play with how this looks like. And it tells you down here for what kind of number of pointings you need for these observations. So this is not allowed. So in a science goal, you're only allowed to have at max a number of 150 pointings spread over the number of sources that you have. So you have to be a bit careful how big your mosaics get. If you want to do several mosaics or a really large region, then you have to put in different science goals to break this up into pointings of less than 150. Good. So now we have a source, we have a mosaic. Let's go back to individual pointings and something simple. So now we can go further down through here. So we have our sources. We can now go show the calibration setup. So for most people, it will just say you don't have to do anything here, so you can just keep it as a system-defined calibration. However, you can also use this one. This is for increased flux calibration. So you can force a separate amplitude calibrator using a solar system object. This is mostly using a solar system object if one is available at the time of observations. If this is not the case, then it will use a grid calibrator, or you can go and use user-defined calibration. And here you can add a query. So for example, you can say, the UOT doesn't give me a check source, but I really want to have a check source. So you can create a query for a check source. You can say, yes, that's fine. Or you can even add a fixed calibrator. So if you say, I really do want to have that exact phase calibrator, you can say, I don't want to have a query, but I want to have a fixed calibrator for this phase calibrator. And you can say, I want to have sidereal target and select it from source catalog. And then you can search around your source. So right now I don't have a search radius, so it gives me just everything. So if you say I want to have something within 5 degrees, then I get all these phase calibrators, and I just want to have this source. This is like my favorite calibrator ever, and I know this is the best and whatever. Then you can go and select this one, and then you get a fixed phase calibrator. When you do this, you have to justify in the technical justification, why are you doing this? So make sure that you know what you're doing here and make sure that you can justify it. So let's go back to system-defined calibration. And then the other important section is a control and performance section. So here you basically enter what kind of angular resolution you want and what the largest angular structure is and what the sensitivity observations is. So this gives you then the timing and also which configurations your project will be observed in. So let's start on the top. You can enter your angular resolution either as a single value or as a range. Or if you say, I don't really care what angular resolution I want, you can click any. Or if you don't want to have any 12-meter observations, you can also say, I just want to have standalone ACA observations. So in single, we can then add, for example, value of 1 second. And so if you have a point source, you can go and just put 0 here. Or if you have an extended source, then you can also specify that and put a bigger value. And then you have to specify what kind of sensitivity you want for your pointing. And for that, you can, for example, put Jansky. And then depending on your observations, you can choose over which channel width this sensitivity is calculated. So which bandwidth should be used to get this sensitivity over. And for spectral line observations, there are different options. For continuum observations, you always get it over the aggregated bandwidth. But for spectral lines, there are all these options here, and the default right now is the representative window effective channel width, which is different from the spectral resolution that is shown here in your representative window. So there's a slight difference in value. If you say all of this, then you can actually, now you can say, okay, how much time does it cost me? And you can see in the planning and time estimate if it's reasonable. And you see, yeah, it only takes an hour to do these observations, so that seems to be fine. And you can see down here now what kind of arrays are necessary to do these observations. So you see with 1 arcsecond resolution in band 6 what the observations was. So at like a representative frequency of 230 gigahertz, I'm getting configurations 3. But since I put a large angular structure for my source, I also need, in addition, ACA and TP observations to cover all these scales. And that's why this is set to yes. But instead of single, you can also put a range, for example. So you can put here values of 1, let's say 0.5 to 1.385. And then you can go here again to planning and time estimate, and you see that it gives you different options for your configurations, because you're giving a quite big range of spectral resolutions. This can be covered by different configurations. If you select any, then this will give you any short baseline configuration. So between C1 and C6, and you see this also here, if I go here, you see this all gives you different options. Or if you go to the standalone ACA, then you only have to say, what's my largest structure in the source? And again, I'm putting this, and then you don't get any 12-meter observations, but you get the ACA, and in this case also the total power, because the angular structure is larger than what the ACA can recover. Good, so there's also different things that you can specify here. So let's go back to single, and you see the OT actually remembers what you put in before. So you can say, okay, this is kind of giving me too short of observations, so I want to override what the OT is saying. So instead of the, whatever it was, 1 hour, this doesn't work, yes. 1 hour observations, I actually want to observe this source for 10 hours, because I want to have a very good QB coverage, for example. So this is also possible, but then you have to justify in the technical justification why you're making this choice. Now that we have 12-meter observations and ACA both scheduled, you can also say, oh, I want to have this simultaneously observed, because for the science that I need to have this data taken at the same time. So you can click here, yes. But then what happens is, so for now this looks the same, but if, for example, we go for something that needs a second 12-meter array, which is anything above C4, so if we go to slightly smaller range, you see that normally this now schedules C4, and if I do not do simultaneous observations, you see that normally you have C4 and C1 scheduled. But since you cannot have two different arrays that are at different times of the year simultaneously, the OT will then skip the more compact configuration when you click here on yes, and you see this is not scheduled anymore. There is a warning now in the OT that makes users aware that this is happening. You can also say, okay, my observations are time constrained, and you can say either if you want to have single visit, you can go click here, and you can specify different suitable time windows. So this is also okay, and you can change them, clicking on them and edit, and you can put a different day, for example, a different year, what I'm doing here. Or you can say, no, I want to have multiple visits, and you can say this is, for example, this is triggered, or you can edit this and this is on a specific date. And then you can add subsequent visits to this. And you see now these visits are actually always specified as dependent on the first visit. So this is like scheduled 14 days after visit 1, 28 days after visit 1, but you can also change this again by editing, and you can say, no, I want to have this 28 days after visit 2, and close this. Fortunately, that always makes the margin go away. You have to go back in and say, okay, you can also do this like that. So you can also put on time windows in this way. Good. And then the last thing to fill out is the technical justification. So you always have to justify the bandwidth used for sensitivity, for your line observations, the angular resolution that you chose and the largest angular scale, your correlator setup that you chose, and then there are different choices to be justified. For example, as I said, if you put in, if you override the timing for the OT, or if you use a user calibration, these all need to be justified here. So if we fill this out now with some random text, it has to be at least 50 characters. Then we can see if, so now everything should be filled out for the OT, and we can say, okay, I'm done with my proposal. Does it actually validate? Did I do everything right? If you want to know this, and you go up here and push the validate button, And then the OT will check on everything you've done and see if there's still something wrong. So now it tells me no, the way that you put your largest angular scale, this does actually not work. So either you have to put in a map, a mosaic, or you have to reduce your largest angular scale. Okay, maybe my source is not quite as big. Let's say it's 30. Let's see if the OT is okay with it now. And it says no problems found. And if this is the case and you're happy with your proposal, you can go up here, file, and then push submit project. I will not do this now because I would send it directly to ALMA, and this is a fake proposal. But this this sends it in to ALMA. You can resubmit your project as many times as you want, all the way up until the deadline finishes. But be aware that right before the deadline, then of course a lot of people are submitting, so it takes a bit more time for the OT to submit your project. So don't put in big changes right before. So this is all for a regular proposal, and I said there are also specifics for the other ones. So first, let's say we have a regular proposal, but we want to do it a joint proposal, which is possible now with JWST, with the VLA and the VLT.
Sorry, Gata, before you move on, we have another question.
Yes, go ahead.
They ask, does the largest angular scale have to be smaller than the total area of the pointings? I assume of a mosaic?
Yeah, I think it has to be smaller than what TP can cover, basically. But that's a good question.
Okay.
Yeah.
No further comments. Oh, thank you. Okay, so it answers the question. Thanks.
Okay, so let's go back to joint proposals. So there are two different types of joint proposals, either ALMA as the main observatory or ALMA as partner. This means that main or partner is decided on how much time you're asking for. So if most of the time is on ALMA, then ALMA is the main observatory. If one of the other partner or the other observatories, there's more time requested, then ALMA would be a partner. And you can add partner observatories here. So for example, JWS2, VLA, VLT, and you can add all, you can add all three. If you know the project codes already, you can enter here, but it's not necessary. And here you have to put what kind of time you're requesting. So you can put it like this. And I think right now I'm still asking for 1 hour. Yes, 1 hour with the OT. So if I put it in like that, you will see that if I justify this now, because I'm saying that ALMA is main, but I'm asking for more hours on the others, you'll see that the OT should not complain. So you see that the rest of the time at one of the partner observatory exceeds the time requested at ALMA. So ALMA would have to be a partner. And then I have to say which one of those is the main observatory, and this will be the one that requests the most time. So it has to be this one. Okay. If ALMA is main, then you also have to provide a technical justification for the different telescopes that you're asking for. Can you do this also with a large program? And you see, yes, this works as long as ALMA is the main. So ALMA cannot be a partner. So you cannot put in a large program, whatever that means, for the VLA and ask for more hours than for ALMA. But you can add a small program on the VLA, for example, in a large program with ALMA. So this would then go the same way. So what else is specific for a large program? Of course, your observations have to be long enough. So right now, the OT would complain because I'm only asking for an hour, and this is not a large program. You see, minimum time for a large program has not been reached. The minimum time is 50 hours on the 12-meter array or 150 hours on the standalone ACA. But let's say we're asking for enough, then what is different for a large program is that instead of the science case, you have to put in a science case plus management plan, which is up to 7 pages. And you also have to include a team expertise document, which is up to it's 1 page. And what I also mentioned earlier, for this cycle now, PIs have to confirm that the scheduling of the proposal is feasible by clicking yes. So you have to check that the time is available for your configuration in LST range is actually larger than the time that you're requesting for a large program. So these are specifics for large program. Then there also are target of opportunity observations. What is really specific for target of opportunity observations is only that it is possible to set your coordinates to 0, 0 if you don't know yet if it's a trigger, and you don't know yet which source you will be observing. So the OT will be okay with you setting 0, 0 coordinates. Otherwise, it will give you a warning as well. And then for phased array or VLBI observations, so as I said, there was an iTrain already that goes into more detail for this. So maybe have a look at there if you want to know more about it. But what is special here is that you have specific spectral setups, so you cannot just choose whatever you want to do. There's only certain continuum setups that you have, and spectral line can also only be done in certain bands and with certain correlator modes. What is also specific is that in the control and performance section, you don't have the angular resolution or so on. You actually have to give the time that you want to observe your project for. And this is the total time for your science goal. So if you have several sources, which is possible now for cycle 11, in your science goal for VLBI, then whatever time you give here is broken up over those sources. And you can specify in the technical justification how this time is supposed to be spent on your sources. One more thing that you also have to specify for VLBI is if you go to the field setup, you have to say if your target is stronger than a certain values or if passive phasing is required. This is directly set if you go to the phased array observations that are done for pulsars, for example. This clicks at some point. You see that sometimes COT is a bit slow. It doesn't want to do anything anymore. See, even that happens to me. Okay, I think the OT gave up. Let's.
Well, it did pretty well until now.
Yeah. Apparently it doesn't like phased arrays. Okay, so what we can do is just kill it. Sorry, everyone. Let me just reopen it. So what is different for phased array is that basically passive phasing is clicked directly, but otherwise it's very similar to the VLBI setup. So the only other thing that I want to talk about is solar observations. If you have specific questions about solar observations, there's the check note has a lot of experience with this and a lot of experts on that topic, so you can also contact them if you have questions. But if you do want to do a solar system object, so you can click here and you can specify the name, so you can do one of the planets or moons of the planets, or you can do the sun. And then for the sun, this looks a little bit different, as you can see here. So you have to load an ephemeris file for your observations, and you have to say what kind of solar activity level you want to observe, so active sun, quiet sun. And again, you can say individual or rectangular field. And you can say here in TP mapping if the full solar disk is supposed to be mapped or if it's regional mapping. This is not quite my field of expertise, so if you have questions there, again, I think the check note can help you much better than I do. And yeah, this is basically the walkthrough that I wanted to give you, and now I would like to open the floor to questions if people have questions.